Hi, this is Mark Miller with OWASP 24/7. We've been following up on the Struts incidents over the last week, including the Equifax breach. I'm here today with Brian Fox, the CTO of Sonatype, and with Mark Thomas, one of the directors at the Apache Software Foundation. So thank you both for coming.
Thanks, Mark.
Thank you for having me.
Sure. Well, Mark, when Brian and I were talking about people that we would like to speak with about this incident, one of the first names that came to the top was yours because of your prominence in the security and the trademarking at the Software Foundation. What I'd like to concentrate on in our discussion here is, can we surface the process that goes through when you guys find a vulnerability? What is the process for announcement and things that you do as part of that process?
Sure. Our vulnerabilities come in via email. They'll either come in directly to the project or to our central security team. If they come to the central security team, then we validate them to make sure that they look sensible and that they're not just spam. And providing that they are, then we send them out to the relevant project team and ask the project team to investigate further. Fundamentally, at the ASF, it is the individual project teams that take the lead in assessing the vulnerability and resolving it. The central security team is there to provide help and advice and coordination, but the work is on the shoulders of the project team, simply because it won't scale any other way. So it's a fairly standard vulnerability handling process. The team will assess the vulnerability, determine whether it's valid or not, open up a dialogue with the reporter so they can confirm that they've received it, ask any additional questions they've got, ask for any additional material they may need. Once they've done that, then they'll assess it. Sometimes they'll ask us for advice, but usually it's fairly obvious whether it's a vulnerability or not. If it is, then they'll start investigating what a possible fix might look like. Obviously, all of this is still in private. None of it is public at this point. Once they've identified a fix, then they'll usually discuss that with the reporter to give the reporter an opportunity to comment on the fix, validate that the fix is correct. And then we get to the slightly interesting part, because this is, of course, open source. Ideally, what we need to be able to do is commit the fix without anybody realizing it's a security fix. And it does depend on the nature of the fix, how obvious that is. The more obvious it is a security fix, the faster we have to work. The less obvious it is, then the more time we've got. Because really what we're trying to make sure is we get to the end release before somebody is able to reverse engineer the fact that there's a vulnerability and what it is from whatever commit they've just seen go past. So once we've identified the fix, then that will be committed, and then depending on how obvious a security fix it is, then the release process will start behind that. Our release process runs over a number of days to give people an opportunity to review the release. For critical security fixes, we can speed that up to as little as we need to. We can get releases out in hours if it's deemed critical enough. Doesn't happen very often, but it can be done, and it has been done. So we get the fix into a release, we roll the release, we start the release process, we get the release out there, and then the release is announced. And then at some time that could be anything from 0 seconds to several weeks, the vulnerability itself will be announced. And again, there are a number of factors that determine that time frame. Obviously, the more critical the vulnerability is, the sooner we want people to know about it. But equally, we want to give people a chance to upgrade to the new release before we announce that there's a vulnerability and give the attackers the details as well. So there's always a bit of a trade-off there as to what that time frame should be, and that is something that the projects will decide on, because they're the ones that know their software, know their community, know what the right balance is to judge for them. So once the release is out there, as I say, a period afterwards, it could be at exactly the same time, it could be a little while later, the vulnerability is announced. That announcement involves informing MITRE of the details of the vulnerability, so that it can go onto the CVE database. We will announce it to everywhere that we would normally announce a release. So taking a Tomcat as an example, a project I work on quite a lot, Tomcat will announce releases to its users list, its dev list, its own announced list, and the Apache wide announced list. So we send security vulnerability announcements to exactly the same list. So anybody who's watching for Tomcat release announcements will see the security announcements as well. We also send it to a couple of public mailing lists. They sort of they varied over time as sort of the community's focus has shifted from one mailing list to another. I think currently it's OSS security where they go to. But in the past, they've gone to bug track, they've gone to full disclosure, as I say, depending mainly on the popularity of those particular lists for the people that need to see our announcements. And that's broadly it.
Brian, you and I have talked, thank you, Mark. Brian, you and I have talked quite a bit in the last week about from the time that a release announcement is made, a vulnerability announcement is made, and the fix is made, how much time there is for the exploitation to happen before people start fixing things.
Yeah, I mean, after the vulnerabilities are announced, I think Mark, you can speak to this as well. I think we see many of the active exploits of that vulnerability happening after the announcement, right? And so it's a tricky issue when you're an open source foundation doing everything in the open. How do you follow the 0-day process properly? And Mark laid it out. I think they do a good job. And yet, even after you put all those announcements out, even after you wait for the release, many people aren't taking action, right? And that's something I've been talking about for years. It's something we've been trying to help with at Sonatype for years, to close that gap from when the vulnerability is announced to when people know about it, at the right levels in an organization and are able to actually start remediating their applications. We talked about the fact that many people don't even have the inventory. They don't of the applications, let alone what components are in them. So when these things happen, they're scrambling, trying to figure out where they're affected and whatnot. And I think people just don't have a good enough understanding of this process that organizations like the ASF go through to try and get these things done on the back end. Mark, have you seen? My opinion is that most of the exploits happen after the announcements. So no matter what you do, no matter how good of a job you do keeping it secret, after you put it out there, that's when people are really the most at risk, right?
Generally, yes. I think that is the case. One of the things certainly that we try and do is, and again, it's a balance, is to provide end users with enough information to work out whether or not they're vulnerable without giving an attacker a recipe to perform the attack. And again, it depends on the vulnerability as to how easy that is to do. But if I had to choose between the two, I would always lean towards more information so an end user can determine whether or not they're vulnerable, because fundamentally there's more of them, and they need that information. They need to be able to make that decision. But I agree with you completely that there are lots of folks out there that don't have a handle on what they're actually running, and that makes it extremely difficult. As does the volume of security vulnerabilities. I mean, IT environments are complex beasts these days. Yeah, you are, even if you know everything you've got, you're going to be dealing with a fairly large stream of vulnerabilities, and that then gets you into the difficulty of, well, how do I figure out which ones I actually need to worry about? Because again, talking from my Tomcat experience, it is often the case that, well, yes, there's this vulnerability, but only if you're using this feature with this configuration setting in this version range. So if one of those doesn't apply, you're absolutely fine. You don't need to worry about it. And being able to understand the vulnerability in enough depth to be able to make those judgments as to whether or not you're vulnerable requires a skill level that I think, again, there is a general shortage of. It's a difficult thing to do.
Right. If you give them, the easiest thing you'd want to do is, here's a test case to find out if you're vulnerable, but that's exactly how the lean back attackers are gonna exploit it, right?
Yes, in most cases. And again, it does. There might be a few vulnerabilities where you can test for it without exposing what it is, but there's not that many of them. Generally, as soon as you start down that road, then you're basically laying out exactly how to perform an attack, which is what we try not to do.
That's right. And given the fact that what you fixed is all right there in the open source, anybody, as soon as they know, they're going to go look at it, right? And most of them, I mean, sometimes they're obscure, but most of them are pretty straightforward, I think.
Yes, and again, it's back to that, how much information do you provide? And we recognize that, yes, it's open source, so it is going to be possible to go back, look at the commits, work out what it was, and reverse engineer an attack. But at least by not handing the attack on a plate, you require a certain level of skill to be able to do that. So you add a little bit of a delay. It's possibly not much, but it's, we do what we can. But that all of these things, it's always going to be balances and trade-offs. But that's what security is all over.
Mark, one of the things that I've been looking at over the last week too is obviously the Equifax thing. It was like a grenade in the middle of the table here. But it seems as if the Struts team had provided a fix for that specific vulnerability in March. And then the Equifax team found it somewhere between May and July. And then we had the big blow up last week. How does something like that work?
From what perspective? In what sense?
I mean, from me, not as a consumer. Well, I guess as a consumer, if you want to think of it that way. How could a company like that have the ability to fix it, or why would they not fix it? What was going on as far as the processes at a company like that in upgrading their software?
The short answer is I don't know. As far as I'm aware, there's been no direct communication between Equifax and the Apache Software Foundation. So I really can't speak to what their internal processes may or may not have been. Based on the limited information I've seen that has come directly from them, it does look like they detected the attack and then went back and identified how it had happened, rather than identified that they were exposed to this vulnerability and then discovered the attack. But beyond that, I have no more information in terms of how their processes worked and exactly what happened.
I saw some pretty detailed information, a rundown today, with some actual specifics. It looks like they had a number of web applications that included things like their secure keys and passwords to databases. And so, once you start getting in that, it's not hard to imagine once you get into the application, if that application has the keys to the rest of the kingdom, it's not hard to go, leapfrogging from place to place, right?
Absolutely. I mean, and this was a remote code execution vulnerability, which is as bad as it gets. So that essentially means that the attacker is controlling the web server, and they can do anything the web front end can do. Now that does make it very difficult to restrict what they can do from that. So if the web front end can read the data, then the attacker is going to be able to read the data. There are things you can do around monitoring access patterns and looking for unusual behavior. There are ways you can write the data access to lock down exactly what the web application can do. You can only run these exact queries. You can't just pick your SQL and execute it. But all of those things add complexity to the development process, add risk to the overall process. So again, it's going to be a trade-off as to what people end up doing.
Right. So I think, Mark, we've spent a lot of time talking about the basics how to avoid these types of things, keeping up to date on the components, closing that first mover advantage so that you can respond accordingly. I think based on some of the stuff I saw today, I think it's worth reiterating, some of the basics. Make sure your application server is not running as root, right?
Absolutely. Yeah, definitely.
So when they get the ability to execute code, hopefully it would be fairly limited. I don't know that if that was or was not the issue here, but the other issue is just a pure basic separation of concerns. Why you would have accessible to a public-facing application things like the AWS keys and other certificates and things like that, literally the keys to the kingdom, why those would be in an application that is remotely accessible in the first place is just a basic separation of concern issue. So
yeah, that definitely strikes me the sort of thing that should be in the layer that the web application accesses, not in the web application. Definitely. That's
right. They shouldn't even be there, or if for whatever reason they are, they should be completely isolated, locked down to the internal network, right? And so it's sort of you need to construct a series of doors. If somebody breaks in one, they've got more, right? Versus putting all the keys to the rest of the doors behind that first outer shell. Not a great idea.
Yeah, certainly. I think a layered approach to security is one that merits a much closer look in many organizations. There is certainly, I think, too much thinking, oh, we've got this, it's secure, that's okay. I think there's very little thinking, well, what happens if that gets breached? How bad is it? And that's really the approach that people need to be taking. That's right. But that's hard. It adds complexity, it adds time, it adds all the things that organizations are trying to reduce. And as ever, it comes back to being a trade-off. And the difficulty with the trade-offs that relate to security is generally you make the trade-off a long time before you feel the impact. If I'm sure if they had a crystal ball, they might have done things slightly differently. Heck, if they had a crystal ball, I'd quite like to borrow it because there are all sorts of things I could use it for. But that's the you're looking at it's hard to justify when you're talking about what's effectively an abstract risk. Well, if you say I need to spend 2 weeks building it this way, and it'll reduce our risk of this happening some guesstimated percentage, or I spend a day doing it this way, but there's a greater risk. And it's, well, trying to weigh those up is actually really difficult. And just trying to quantify them is really difficult.
I think part of the issue is just how people think about it. There's a lot of effort spent on making sure these things don't happen versus, on the traditional network layers and those types of things, and even some of the best practices we've been talking here. But it feels like in a lot of cases, nobody's sat back and thought through, the fact that this is going to happen at some level. And so what do I wish, when this happens, what do I wish I hadn't done, and take a look at that, right? And I think having keys and stuff in a public application ought to come up in that thought experiment, even if it wasn't designed out in the beginning. And assuming that these problems are going to happen, we talked about that yesterday. Bugs are going to happen. Humans are writing the code. We make mistakes. Some of those mistakes lead to vulnerabilities. But being able to respond to them, all those types of things. If you sit back and really have that thought experiment, pretend it happened. What do I wish I could undo? What would I do differently? You don't have to actually be exploited to go through that thought experiment. And I think it might be illuminating to a lot of people.
Absolutely. I think just about every talk I've given on security, at some point there's been a slide or two there that says, just imagine, because I'm normally talking about Tomcat. Just imagine there's a critical Tomcat vulnerability announced tomorrow.
Right.
That you're vulnerable. What are you going to do? How are you going to handle it? Sit down and discuss it and figure out your plan now, while you haven't got 10 layers of senior management jumping up and down yelling at you to fix it yesterday, and come up with a plan so you can, hopefully if, but let's be honest, probably when it happens, you can just say, okay, it's okay. We've got a plan. We don't need to panic. We know we do this, and this. We can do an emergency upgrade, and we're fine. And that small upfront investment, as you said, just thinking through the what ifs and putting that plan together can have a huge benefit down the line.
That's right. I think if somebody did that, they'd immediately realize, well, wait, we don't even know what our applications are. We don't know what's in them. So the things that I've been talking about ought to be, you know, those oh boy moments as soon as you go through it. Right?
Yeah, yeah. You really do want to take the opportunity to work through it now calmly before it happens. I think if there's one message to take away, I think that's it. Yeah,
you could
definitely
turn that around to vendors or other software open source projects, but it really applies. I mean, we've had vulnerabilities in our stuff, as everybody does, right? I think the extreme one affected our repo a few years ago, and you know, we hadn't had many before that, so that one was a learning experience. But the ones that have come since have been a little bit easier because we kind of have figured out the right process. But if you are producing software, whether it's components or end user software, you need to think through the what if you discover there's a problem in your stuff and it affects your end users. How are you going to handle that particular communication path? And that's some of the stuff that, Mark, you've been talking about the ASF does. And I'm sure it's written down and documented somewhere publicly. You know, as a process guideline, people should take a look at that because, you know, being ham-fisted in the response is often worse, right?
Yeah, definitely. It's down there at www.apache.org/security, and that sets out our process, and there's links that go into more detail there. And that's essentially the process that I've happily copied and applied at a number of other organizations, and it works whether it's open source or closed source. It's a fairly generic process. So yeah, if anybody's interested, then it's there for anybody to have a look at, and feel free to reuse it. Definitely.
Yeah, you should go look now for familiar.
That's what I was just going to say that.
So that when it happens, you at least have a framework. I mean, I know from my proximity and watching what happens at the ASF, you know, through Maven and being part of infra and stuff, when it was our time to deal with it, I knew exactly where to look. I was like, wait, I've seen Mark's talk. I know how this is handled at the ASF. I know it's written down. Let's go take a look at that before we start, you know, just greenfielding this, because we don't have to reinvent this wheel. And so, you know, that's a takeaway. So takeaway, if you're an end user, you know, go through the thought experiment. How would I know if one of my third-party components were vulnerable? What am I going to do about it? And if you're producing software, you know, imagine the same thing and think about how you're going to notify your customers and do so in a sane kind of way.
Wholeheartedly, big +1 to that.
Mark, that leaves a closing here that I'm wondering is, what should developers and companies be doing this weekend to prepare for next week? Is there any cherry pick in the stuff that you've got there that people should be looking at and could easily be implemented?
I think it is just exactly what Brian's just said. If you haven't got the processes in place, have a think about what those processes might be. Take the time just to run a little thought experiment, that, well, the what ifs, and think about what are the worst case what ifs for you, how you might deal with it, and come Monday, start discussing with your colleagues, well, how would we deal with this, and come up with it, even if it's an outline plan, something calmly discussed and bounced around now is going to be invaluable should you ever find yourself dealing with the panic situation in the future.
Yep, those panic things, they don't come at convenient times. They can come just before a long weekend. They can come before a big holiday. You don't want to be figuring it out then. I think we've lost Mark's audio. You there, Mark?
I see myself talking, but my mute button was on, of course. Mark, thank you for your time. I know it's a busy time for the Apache Software Foundation, but we very, very much appreciate the work you guys are doing, the projects and everything is going on. So thank you so much.
Thank you very much, and thank you for having me.
Sure.
Thanks,
Brian, as always, good to see you. All right. So Thanks for joining us. This is Mark Miller with the OWASP 24/7 podcast. We're keeping up with our series on the Apache Struts announcements that have come out in the past week. Keep an eye out for some more broadcasts. Thanks.